Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at an MCQ question from the IB Chemistry Paper 1HL from May 2021. So this is the most recent paper that we have. And this is actually the set of papers from my batch, the exam that I was going to give. However, last minute, they got canceled in my area, my country. So I didn't end up giving this paper, but it was nice to look at what I could have written. And in a whole, the paper is not difficult. In my opinion, as I skimmed over it, I realized that the questions are actually quite simple. And I'm going to be solving them one by one in the upcoming days. And this is the first question that I would like to start off with. So it's the 30th question. It asks us, which gives the equation and cell potential of the spontaneous reaction? And now over here, they have given us two reduction reactions, and they have told us the E0 or the electrode potential of these reactions. So for Mn2 plus to be reduced to Mn, the E0 value is negative 1.18. And for silver to be reduced, for a silver ion to be reduced to silver, it has an electrode potential of positive 0.80. Now, based on some things they have given us in the question over here, we can automatically eliminate two options, right? This is how I like to approach MCQs. It's a good strategy to first eliminate options that are unlikely or that you think are wrong. So we can automatically eliminate two options from this, and that is A and C. A and C are not going to be the answer. And why is that? That is because, as you can see, the electrode potential or the E0 value for A and C is negative 1.98 and negative 0.38. And this goes actually against what is told to us in the question. In the question, it tells us that it is a spontaneous reaction, and a reaction which has a negative E0 value cannot be spontaneous. And why is that? That is because if you remember the Gibbs free energy equation for redox reaction, because how do we know if something is spontaneous or not? We calculate the Gibbs free energy. And if we want to calculate the Gibbs free energy of a redox reaction, this is the equation, right? This is the equation. It's negative N F E. And what is this? Negative N times F times E. And what is each of these exactly? N is just the number of moles of electrons. F is something called Faraday's constant, which is 96,500 joules. We often convert this into kilojoules. And E is E0. So supposing if E0 is negative, right? If E0 is negative, and since we already have a negative sign in the beginning, negative times negative gives us a positive. And we all know that if Gibbs free energy is positive, then the reaction is considered as non-spontaneous. So if we want Gibbs free energy to be spontaneous, it needs to be negative. And the only way it can continue to remain negative in this equation is if E0 remains positive. Thus, we can eliminate A and C, which give us negative E0 values, which is wrong, right? That goes against what the question is telling us. The question has told us that it's a spontaneous reaction. A and C make it a non-spontaneous reaction. Now things are a bit easier for us, right? We're left with B and D, and both of them are positive. But how exactly would we approach the correct answer? There are two ways you can do this. I'm going to show you the way which I find easier, and then I will go on and I'll explain the other way as well. But it really depends on what you find easy. I'm just going to erase this real quick so I can explain it to you. Now, based on the information given to us in the question, right, we have been told that the electrode potential for this reaction is positive 0.8. And we know that the more positive the electrode potential for a reaction, the more likely it is to happen. And what I'm saying essentially is that this reaction, the forward reaction for silver to gain an electron and to become Ag, there is a higher chance for this to happen than for Mn2 plus to gain 2 electrons and become Mn, because Mn has a very low E0 value. This is the E0 value for Mn2 plus to gain 2 electrons and become Mn. And what this essentially tells us is that Mn is more likely to be to be oxidized than to be reduced. So Mn likes to be oxidized. And what is oxidation? Oxidation is giving away electrons. Reduction is accepting electrons. So the lower the E naught value, the more likely that substance is to be oxidized rather than reduced. And the higher the E naught value, the more likely it is to be reduced or gain an electron. So based on this reaction, what we should be able to deduce is that this, where Ag gains an Ag plus gaining an electron, is more likely to happen. And thus, this, where Mn gives away 2 electrons, is more likely to happen. So in this reaction, all in all, Mn is going to be the reducing agent and Ag plus is going to be the oxidizing agent. So reducing agents reduce other things and oxidizing agents oxidize other things. So based on these two reactions, only in one of the reactions is Mn acting as a reducing agent, and that is in B. B is not the correct answer. So if you look at it, let's take a look at B, and let me show you why that's wrong. In B, what we see happening, this is B. In B, we see that Mn is being reduced. Mn2 plus is gaining 2 electrons from Ag to become Mn. And that is wrong, right? As we said, based on the electrode potential values given to us, Mn is more likely to be oxidized than it is to be reduced. So this is wrong. However, D is the correct answer, because in D, we see that Mn is going to give away its electrons, or it's going to be oxidized to Mn2 plus, and we are going to gain 2 silver, which is correct. That makes sense. So that is one way that you can get to the answer, and that is based on the E naught values. Higher the E naught value, the more likely it is to be reduced. Lower the E naught value, the more likely it is to be oxidized. What is the second way that you can reduce this? Well, it's actually quite simple. It's more of a derivative of the first method. You have to do the first method regardless. You have to determine which is going to be reduced and which is going to be oxidized. And then you can make the judgment based off the numbers given to us over here. So suppose you have determined, okay, I know that Ag plus is going to be reduced and Mn is going to be oxidized. And we know, how do we calculate the overall E naught? So how do we calculate the overall E naught of a reaction? Well, how we do that is a process, or what I like to think of it is cathode minus anode. So the E naught value of the cathode minus the E naught value of the anode. And the cathode is where reduction occurs. So cathode is where reduction occurs. And where is reduction occurring in this case? Well, it's occurring at Ag plus. So what is the E naught value of Ag plus? It's 0.8. And what is the E naught value of the anode? Anode is where the oxidation occurs, and that is negative 1.8. Sorry, 1.18. So if we do this, if we do the math, 0.8 plus 1.18, it gives us 1.98. So hopefully that makes sense. Thank you so much for watching. If you have any questions, please feel free to reach out to me on my Instagram. I'm helping students almost every day, even though if I've not been very active in uploading videos, I still respond to my messages and I'm still open to help. So thank you for watching. Take care of yourselves, and I'll see you in another video with another question. Goodbye.